In this lecture, we'll be starting up straight away with semantic networks. So, the formal definition of semantic network is that a semantic network is often used as a form of knowledge representation. What it is? It is a directed graph consisting of vertices which represent concepts and edges which represent semantic relation between the concepts. So semantic networks consists of vertices, and the vertices are connected by edges. These edges represent the relations or the semantic relations between these vertices, right? Now the following semantic relations are commonly represented in a semantic net. The following semantic relations are commonly represented in a semantic net. What are they? Now they are meronym, 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 holonym, hyponym, hypernym, synonym, and antonym. Now let us see each one of them one by one. These are what? Now these are the semantic relations that are commonly represented in a semantic net. So in a particular example of a semantic net that we are going to see later, like this one that you can see here, they consist of all these components. These six components. Let's start up with meronym. Meronym is what? Now meronym is a situation when A is a part of B. Meronym is a situation where A is a part of B. For explanation, meronym is a term which denotes a part of something but which is used to refer the whole of it. I repeat it once again. Now when we talk about meronym where A is a part of B, we say that meronym is a term which denotes a part of something but which is used to refer the whole of it. Like faces, FACES, faces. A good work by a particular individual uplifts the face for that particular community. Here, face is a generalized term for a body part, that means a face of a person, a particular person. It is a specified part for a particular individual, whereas it is represented to represent the whole of it, right? So in case of meronym, A is a part of B. Let us come down to holonym. Holonym is what? Now A has B as part of itself. B has A as part of itself. Holonym is B has A as part of itself. So the formal definition of holonym says a term that denotes a whole. I'm sorry, this dog is shouting like anything. Holonym, a term that denotes a whole whose part is denoted by another term. A term that denotes a whole whose part is denoted by another term. For example, body is a holonym of arm, leg, and heart, right? So holonym is what? Now holonym is a term that denotes a whole whose part is denoted by another term. Example is body is a holonym of arm, leg, and heart. Next comes the hyponym or the troponym. A is subordinate of B. A is kind of B. A is subordinate of B. A is kind of B. So let us see the definition of hyponym. Hyponym is a word or more specific meaning than a general or a superordinate term applicable to it. I repeat, a word or more specific meaning than a general or superordinate term applicable to it. Example is spoon is a hyponym of cutlery. Example, spoon is a hyponym of cutlery, right? Now comes hypernym. Hypernym is a condition where A is superordinate of B. A is superordinate of B. So, hypernym's definition is that a word with a broad meaning constituting a category into which words with more specific meaning falls. A word with a broad meaning constituting a category into which words with more specific meaning falls. So, hypernym is what? A is superordinate of B. So the example is that color is a hypernym of red. That means I am talking about color means color defines all the set of colors. That means A is a superordinate of B. Now comes the synonym. Now what is the synonym? A denotes same as that of B. We call it like synonymous terms. Something is synonymous to another thing, right? Antonym. Antonym is what? Now, A denotes the opposite of B. It is just the reverse of the synonym. Likewise, hypernym and hyponym, these are also the reverse of each other. This is the reverse of this is the reverse of this. Antonym is the reverse of synonym, synonym is the reverse of antonym, and meronym and holonym, they are exclusive, right? Let us see an example. In this example, the physical attributes of a person can be represented as in the following figure using a semantic net. Now, the physical attributes of a person. Who's the person? Mike Hall is the person. Mike Hall is the person. He's having an instance as a person, and he can be further generalized as a mammal. So Mike Hall's instance is a person, and he is also a mammal and has a body part that is a head. So Mike Hall's instance is a person, and person is a mammal. Mike Hall does have a team for which it plays. It's Cardiff, and the team colors are black and blue. So this is what? Now, these are the physical attributes of a person, and they are represented in the form of a semantic net. So Mike Hall's semantic net is, they talk about initially what he is as a specific class of mammal, and he's having a specialized body part of head. Now these are the values of the attribute. That means Mike Hall's specified values are head, mammal, and its instance is a person, and its other values are like other non-instance values are Cardiff, that means his team, and the team's color, right? Now we have an interesting thing out here. These values can also be represented in the logic as, now in the form of an is a relationship, which is represented as a logic. We can write it as person is a mammal, right? This is a formal logic representation of the is a instant relationship. So what we are saying here is person is a mammal. Mike Hall's instance is a person. Mike Hall's team is Cardiff. So we are having three logical representations between person and mammal, Mike Hall and person, and Mike Hall and his team Cardiff, right? This is just the first order logic that we used to write out previously. Again, I'm telling that this lecture note is from the NPTEL lecture series. These are not my materials or study materials. I have taken it from the NPTEL site and I'm using it. Now we know that conventional predicates such as Dave, lecturer, that means how we read it, Dave is a lecturer, can be written as an instance Dave's instance is a lecturer, right? So let us see this sentence once again. We know that the conventional predicates such as, when we are going to show a conventional predicate such as Dave's lecturer's condition as Dave within bracket and then lecturer, it can be written as an instance as Dave instance lecturer. That means Dave's instance is he's a lecturer. Recall that is a an instance represent the inheritance and are popular in many knowledge representation schemes. Generally, the is a an instance is used not just in the AI's knowledge representation scheme, but in most of the knowledge representation methods. Now, up to here, that means up to this part, it is okay. But we have a problem. What is that problem? The problem is that here we can represent one thing at a time. That means how we are going to deal with it when we are having more than one. Like how how can how we can have more than two place predicates in semantic nets. Here we are having one place predicates, that means Dave is a lecturer and Dave's instance is a lecturer, right? Dave's instance is a lecturer. But how we are going to deal with it when we are having more than two place predicates in a semantic net? Example, Cardiff and Lanali, they are having a score of 23.6. Cardiff's score and Lanali's score is 23 to 6. 23 tier 2 6. That means Cardiff has scored 23 and Lanali has scored 6, right? So this is a two place predicate semantic net. So two place predicate semantic net is a little different from the conventional logic based representation and its instance representations that we have seen. So this paragraph is very important, right? So the solution to this previous problem, that means for two place predicates in a semantic nets, as we are seeing here, is here. What we can do now, create new nodes to represent new objects either contained or alluded to in the knowledge, game and fixture in the current example. Now let us read it once more. Create new nodes to represent new objects. Fine, we are doing it either contained or alluded. Alluded means avoiding or simply touching and going. That means somehow bypassing. That means create new nodes to represent new objects either contained or they may just be touched and not comprehensively dealt with in the knowledge, and game and fixture is the current example. Now relating the information to the node and filling up the slots. Let us see how it is done. Let's talk about Cardiff and Lanali. These are the two teams that are playing in a fixture 5, that means the game name 5. That means Cardiff and Lanali, they are combinedly having an instance of fixture 5 where it is having an is a status or an is a inheritance as a game, and they are having a specified value, that means the score value of 23 to 6. Here there is a catch that you need to remember. Cardiff is the home team and Lenali is the away team. Home team means that has reached home. That means that has won the game. So whenever there is a home team or something is winning or something is gaining something or something is getting something, there is an arrow outside from that particular object, right? Here Cardiff is the object and from here one of the arrow is coming out. Cardiff is the object and one of the arrow is coming out and it is going towards fixture number 5. So when it is going towards fixture number 5, so I'm saying that Cardiff has won the game and Cardiff's score is 23, and this thing can be seen very easily here. Cardiff, Lanale, they are having a score of 23 and 6, right? And Lanali is the losing team, that means the away team. It is not towards the home, it is away team in fixture number 5, which is having an instance of, or which is having an inheritance of, in the form of an is a relationship with game, having a score of 23 and 6, right? So this is one of the examples. Let us see a more complex example. Another complex example is that we have a statement like John gave Mary a book, right? John gave Mary a book. Here we have several aspects of the event. What are they? Now, Mary and John, they have an event. This event is what? Now, they are now having an instance. That means they give to each other. They gave to each other what? Now, the object is book. With a book name, that means 69, and its instance is book. You could have said that we could have got another instance like Mary and John are human, but that concept's explanation is not there in the particular statement. The statement says that John gave Mary the book. That means they're talking about a specified book where the instance for the book has been given as book 69, and Mary and John, they are within an event. Event is what? The event's instance is giving, and the event has an object whose name is book number 69, that is book's name, and that book's instance is again a generalized class, that means the book. So we are having two instances, giving and book, for an event and a book number 69. Here also the old rule applies, like Cardiff is the winning team. That means the team that has been homed or that has won. Here John gave Mary the book, right? So John is an agent that gave away, right? John is an agent that gave away, right? And Mary is the receiver. So Mary is winning, that means gaining something, that's why the arrow is going out. And John has lost, that means given a book in an event which is instant as gave out here, right? So these are two of the examples. You have to consult a few more examples from here on. Now, inference in a semantic net. The basic inference mechanism follows links between the nodes. What is the basic inference mechanism in a semantic net? The basic inference mechanism is follow the links between the nodes. The two nodes to do this, the intersection search, and the second one is inheritance. In case of intersection search, what we do is the notion that spreading activation out of two nodes and finding their intersection finds the relationships amongst object. That means the point where we are having the intersection of the relationships between two objects, that talks about the particular node where they are having their relationship. This is achieved by assigning a special tag to each visited node, right? Here we are having one of the examples. In inheritance, we are having an is-a and another one is an instance representation. Provide a mechanism to implement this particular inheritance. Inheritance also provides a means of dealing with default reasoning. Example, we could represent emus as birds. Typically, birds fly and have wings, but emu runs. Let us see how this thing can be represented in the form of a semantic net. This whole thing can be represented in the form of semantic net, like emu is an object which is having an instance as a bird, and emu's exclusive action is to run, whereas emu is a bird and has a body part, that means wing. So the action that is expected is to fly. But emu cannot fly, and emu has an action of running. In making certain inferences, we will also need to distinguish between the link that defines a new entity and holds its value and the other kind of link that relates the two existing entities. What it is like here we are having emu and it is a bird and it is having a special category that it can only run and it cannot fly. But there are certain other conditions where we need to compare. So we need extra nodes for the concepts as well as its value. Let's say I am having Dave and Steve and their heights are given, right? They are having a particular height of 160 and 158. And the question is, whose height is greater? So the special procedure are needed to process these nodes, but without the distinction, the analysis would be very, very limited. Let us see how this thing is done. We are having Dave, we are having Steve, and Dave is having a height of h1 and Steve is having a height of h2. So height of h1 is greater than h2, which is having a value of 160. You could have even put up the value of it is better for you to answer that why we are not putting up 158 here, right? Now, extending semantic nets, partition network, these are the things you will be going through of your own. I mean, this is for your self-study part, and I can put up questions from this part. So you can go through it, right? You can go through it. So this ends our semantic net part. I'll be putting up this whole of the PPT on your WhatsApp group soon. Thank you.